to cover one very interesting topic called lock. Now, if you have taken any computer science classes or any operating system class, you have already learned about lock. Lock is a very important concept when it comes to multiprocessing and operating system concepts. Okay, so let's go over this lock concept. First of all, let's think about why lock is needed in our real life. In our day-to-day life, there are resources which cannot be accessed by two people at the same time. For example, bathroom. Okay, bathroom door have a lock. Why? Because if two people try to access it at the same time, it's really gonna create a pretty embarrassing situation, isn't it? So that's why we protect the bathroom, which is a shared resource, with a lock. Similarly, in programming world, whenever two processes or threads are trying to access a shared resource such as a shared memory, a file or a database, it can create a problem. So you need to protect that access with a lock. What happens if you don't add that protection? I'm going to show that by running this code. So this program is a banking software program, and here I have two processes. You can see them here. The first process is depositing money into a bank, and the second process is withdrawing money from the bank, and in the end I am printing the final balance. Okay, so I'm starting with a $200 balance. In deposit section, I'm depositing $100. So I have a for loop which iterates through 100 times, and in each iteration it will add $1 to my bank account. And similarly, in the withdrawal, I have same loop which iterates through 100 times, and every time it will deduct $1 from my bank account. So in the end, I should have $200 left here. Okay, now I'm using a shared memory variable called value. So if you remember from my previous tutorial, this multiprocessing value is a shared memory resource. Let's see what happens when you try to run this program. Okay, it printed $200 fine. So sometimes it will work, but sometimes it will print inconsistent results. So I'm going to run it multiple times. This time it printed 205. 201. So you can see that every time it's just printing different values. Now, why does this happen? This happens primarily because when this process tries to read this variable called balance.value, which is in shared memory, let's say this has a $200 value. It will read it, and then it will add 1, and then it will put back the same thing into a same variable. So let's say this is 200, and it is doing this addition operation at operating system level. So at operating system level, it will be executing multiple assembly line instructions. Okay, so let's say it read the variable 200, it added 1, and it's gonna write back 201 here. Now while it is doing it, at the exact same time, this instruction also got executed. So although I am depositing first and then withdrawing, what happened is when I try to read this, it will be still 200 because this guy has not returned back to the original variable. Okay, so instead of reading this as 201, it will read this as 200, and it will have 199 as a balance.value instead of 200. So that's why you are getting this inconsistent behavior. Alright, so now let's use lock to lock the access. Okay, so what you're going to do is create a lock variable and use multiprocessing modules lock class. This is how you create a lock, multiprocessing.lock. Okay, and pass that lock to both of these processes. Okay, and now here I am going to say lock.acquire. So to put a lock, you just call lock.acquire function, and then to release a lock, it's a release function. So it's pretty intuitive and straightforward. Okay, so lock.acquire and then lock.release. Now this section of code is called critical section. Whatever part of your code is accessing the shared resource which you want to protect, that part is called critical section. So you always have to put lock.acquire and lock.release around that critical section. Okay, now let's run it. Okay, so now it's gonna print 200 every time. So I'm running it multiple times just to prove that I'm not making this up. It now works. Okay, so the guys who write your banking software, they better use lock, otherwise you will have chaos in your bank account transactions, you know. So using lock is very important. Okay, so that was all about locks. We are going to cover a few more multiprocessing concepts in future tutorials. Learning multiprocessing with Python is extremely easy, and I hope all of you are having great time, and I'm pretty confident all of you